give you some information on it, so that way you guys know what is the expectation for that question. So it helps you a little bit. Let me see. I want to look at it down forward so I can explain it to you. By the way, when you guys do the work, I can see your work like this. It also shows me the name and what is the assignment, and also tells you everything out there. So don't think that, okay, when you guys are doing on that paper at the exam board, I won't be able to get your work, or I won't be able to see your work. So you can see that. That's just evidence up there. So you can see that right away. So it's important to you put your efforts and see this like very nicely done and like that. So I can check it class-wise, period-wise, everything, but just put your efforts. What I mean to say is. So coming back to the homework, just to give you some idea, you see this A, B, C is a triangle. Now we're translating 5 units to the left. When you're translating 5 units left, obviously what we're doing is we're moving this entire picture to the left 5 units. So what you need to do, you can count 5 units and then move at each point and then draw them. Or you take the order pairs. Let me see if I can erase this and then. So you take the order pairs and write it down A, B, and C. And then once you write it down there, and look at the question, what it says. 5 units left. When you're moving 5 units to the left, you take away from the X. Take away from the X. So when I take away from the X, 4 minus 5, that's -1. Where's my other color? So 4 minus 1 is 4 minus 5 is -1. See that? -1 and 8. And then 4 minus 5, that's -1, and then +4. Same thing. 1 minus 5, that gives you -4, and then 5. Those are the new order pairs. And you can go ahead and plot them. So -1, 8, -1 here, and then 8 is right here. That's your A prime. -1, 4, -1 here, and then +4. That's a B prime. And then -4, 5. -4, +5. That's your C prime. So basically, the entire triangle, we translated or moved 5 units left. Okay, move 5 units. 5 units left, or you can say -5. Does that make sense? Hopefully this one will help you to complete your homework, guys. But I want to see more people turning the work. And again, at the end of the day, it's your grade. And everything is for you. So again, as I mentioned to you, lagging out. Okay. So as I mentioned to you, pay attention to the class, complete your work on time. That way I can see a better scores from you guys too. Okay. All right. So don't forget that I am still giving you some points for those who are having the videos on, so that we can get some little bit more points. So that helps you too. Okay. Now let's go ahead and start over today's lesson. I'm going to stop share this one. Present. Book already. Okay, give me 1 second.
Okay, Miss Carrie.
Okay. Now let's look into this one. We're going to take some notes also. I want you guys to have your notebooks ready with you guys, so that way as we go along with this, and we're going to take some notes, so it should make more sense to you guys. Okay.
What's this flash mob business all about?
Ooh, Max, you're gonna love it! A flash mob is when a group of people secretly plan to meet and do something spontaneous.
Hey, I know what you're talking about. Check out this animation of a flash mob starting.
Yeah, flash mobs are crazy! The people who aren't in on it usually have no idea what's going on. Lots of flash mobs involve people planning a secret dance. I think that's what we should do at the Transformations homecoming dance.
Copy that. So where do we start?
How about with the theme of the dance? All good dances include a whole bunch of transformations. Let's warm up by reviewing the transformations we know so far. Match each type of transformation to the motion that's needed to open the window. Then click Done.
All right, awesome. So I want you to guys get ready with your chat box, and I want you to tell me which transformation is each of them. So please get ready. That way you can get your participation points too. Okay, put them in the chat box. Excellent. Very good, very good. So when you see it's sliding, when it is sliding, what do you call? Translation. When it slides, it's a translation because orientation is same. So the translation, the first one. Okay, very good. How about this one? That's good. It's a reflection. It's a flipping over. Excellent. Very good. Okay, as you guys are working up here, I just want to tell you something. I know a lot of you guys already do participate, but this is about like those people. They're kind of like watch and sit and watch. It's not going to help you. Math is when you do it, you put your hands in there, get your hands dirty, so you can make more sense to you. Math is not a storybook. You can read and understand. You do it, makes sense. Yes, it understands. So if you're sitting idly and then watching, it's not going to help you. So put it your mind and soul here. That way it makes more sense to you.
Totally. A translation slides a figure. A reflection flips a figure. And a rotation turns a figure. The original figure is called a pre-image, and the new figure is called an image.
Let's hit pause for a sec. When we were making the sign for the dance, we learned all about translations and reflections. But if we want to plan a great flash mob, we should take a closer look at rotations.
In the last two sections, we learned about the translations, we learned about the reflections. Now we're going to jump into the rotations.
You know, we see rotations everywhere. Picture a bicycle wheel, spinning round and round and round.
Whoa there! You're getting me dizzy. Let's slow down a bit. Here's what I know about rotations. Picture a point moving around a circle. A rotation is a transformation that turns that point around a fixed point called the center of rotation.
You're muted.
Thank you. So when it comes to the rotation, we keep it one point and then you turn the picture or the figure, whatever it is given to you, it's going to turn. So when I put a point in there, that's called center of rotation. So it's really important to you and kind of like write it down. So at this time, write it down in your notebooks. Properties of rotation, write it down. Nicely put it out there. And also the date is 9/3/2020. So, and then also write in nicely rotation. Center of rotation is the point where we use it, center of rotation. Learning the vocabulary is so important because sometimes things happen like, you know how to do the question, but you don't know that vocabulary, what does that mean? And then you're totally like, oh, this means this. I know how to do it, and because I didn't remember what is the vocabulary. It could happen there. So please take a good note. When you take a good note, it will help you. When you need some help, you can go back and look at it. But yes, I've got this. So please take a note. And especially this time, I can't see who's taking and who's not taking. First of all, I don't need to worry about it because this is your learning. I'm trying to help you to bring some other, all the equipment that I can bring it up and then teach you to make understand. But at the end of the day, if you don't write it, then it's not going to affect anything to me, but it's going to help you if you take notes. Okay, so take responsibility of your learning and do it, so that way you have that concepts with you guys. All right, moving on.
The center of rotation is the center of the circle. The amount of the turn is the angle of rotation. A quarter turn around the circle is 90 degrees. Rays drawn from the center of rotation to a point and its image form the angle of rotation.
The next one is angle of rotation. Let's say you have a point, you turn or you rotate, but how many degrees are you rotating? So that's called angle of rotation. So how much angle are you turning around? So that's another called angle of rotation. Please write it down in your notebook. And if you're done with it, just put it in the chat box, done. That way I can move on to. Okay, 10 seconds. So the reason, when I give you guys, I only not just care about those people responding it, but I care about all the people in the classroom. That's the reason whenever somebody tells me I'm done, but I'll give you 10 more seconds. That way the rest of you guys can catch up with the work. Okay? All right, let's move on.
A rotation is clockwise if its direction is the same as the direction of a clock hand.
Very important vocabulary that we need to know is clockwise. There is two vocabularies, clockwise, counterclockwise. The way the clock turns, it's called clockwise. The opposite to the clock turns is called counterclockwise. Clockwise, we can always write a CW. Clockwise, we can say as CW. Clockwise is CW, remember that. Counterclockwise is going to be CW. Sometimes in the questions you see okay, turn this 190 degrees CW. But if you don't know what a CW means, you're kind of lost in there. Okay? Okay, next.
Like the one we just did. A rotation in the other direction is a counterclockwise rotation.
Okay, please write it down in your notebooks. And if you're turning to the other side or the opposite direction of the clock turns, that's called counterclockwise. Okay, so counterclockwise is CCW. Please write it down. This vocabulary is really important in the rotations. The counterclockwise goes the other direction. Clockwise goes to this direction. Good job, guys.
A half turn around the circle is 180 degrees, and the angle of rotation is 180 degrees.
The half a turn, it's 180 degrees. Okay, please write it down. Half a turn, it's 180 degrees. Half a turn is 180 degrees.
A turn 3/4 of the way around the circle is 270 degrees.
So 3/4 of a turn is 270 degrees. Basically, it's 90 plus 90 plus 90. So 90 plus 90 is 180. 180 plus 90 is 270. Okay, that's how you get that numbers out there. So 3/4 of the triangle or turn or rotation, it's 270 degrees.
A rotation all the way around the circle back to the original position is a 360-degree rotation.
So when it's a complete circle or the complete rotation, like when you turn it 4 times, 90 180, 270, 360. You're going to come back to the original position. Okay, it's just like going around and then coming back to the same position.
Thanks for breaking that down for us, Miss Brandy. You're right, rotations are everywhere. Which of the following pictures show a rotation?
Okay, I want you guys to identify which one is their rotation. This is A, B, C, D. Which one do you guys think is the rotation? Okay. All right, thank you. Good job, guys. Thank you for participating. Yes, it's a D, it's a windmill, it's a rotation. Obviously, it's a turning one place to the other place.
So right. There's another rotation. Can you find it?
There's one more in this picture. What do you guys think? Which one is the other one is the rotation? That's right. Good job. Good job, Jay. Good job, guys. So yes, this one is also a rotation.
Perfecto. Both the quilt and windmill show rotations. Look at the quilt. It has a center of rotation. This red parallelogram moves 1/4 turn clockwise.
So you guys can observe that one in the quilt. The parallelogram is right there. The point is called center of rotation. It turned 90 degrees. When it turned or rotated 90 degrees, then you got a next pattern. And if you turn it 90 more degrees, you get the next pattern. So that's how they created patterns. Okay.
Angle of rotation is 90 degrees.
So we totally need to include rotations when we're planning the flash mob dance. How are we going to plan the moves?
I know how we can plan the dance. Remember the app I created to perform translations and reflections? I'll just add the ability to do rotations too, and done. That should help us plan.
That's what's up. For the dance, we can start off by arranging everyone in a triangle. Then we can have them all turn the same direction.
If you want to see how that will look, just place a triangle on the app. Then, every time you click the clockwise button, the triangle will turn 90 degrees around this center of rotation. This is the only center of rotation the app uses. When you click it again, it will turn another 90 degrees for a total of 180 degrees. You can reset the app if you need to. And if you want to turn it the other direction, just click on the counterclockwise button and it will rotate 90 degrees counterclockwise.
Maximil to the rescue again. Let's do this thing. Now you will use the app to match the target. The target is always the blue figure. Rotate the line segment to match the target.
Okay. So in the last one, you guys see this one. Whatever the picture is given to you, you can turn 90 degrees, 180, 270, or 360. If it is turned 360, you're going to get the same picture back again. So it's a really important thing is like make sure in like how many degrees you're turning. And the second thing is clockwise or counterclockwise. Okay. Now I want you to guys match this yellow one with the blue. And I want you to tell me, is it clockwise? And then how many degrees do I need to turn? Okay. Can I turn in clockwise or counterclockwise? Or how many degrees to match that? Okay. So go ahead and then try that. Put them in the chat box. I like that. Clockwise. Okay, that's good. Clockwise is good, but how many degrees do we do it? That's good. I like that. Thank you for participating, guys. Really good. Clockwise is right. Okay, that's good. And how many degrees? Is it 90 degrees or 180 degrees, 270 or 360? Okay. All right, pay close attention. So this one, the yellow line to match it with the blue line, I can just make a turn because this is how the clock turns. So I can move it 90 degrees clockwise, or I may do this way too. That's 90, 180. If I click it one more time, it can go back to the image. So what we can do We can do 270 degrees counterclockwise or 90 degrees clockwise. Or I can do it clockwise.
There you go. You rotated the line segment from its original position to the target. You can rotate the line segment 90 degrees clockwise or rotate it 270 degrees counterclockwise to match the target.
So you can see that it's 90 degrees clockwise. You're going to get the same as if you turn it 270 degrees counterclockwise, because 290 plus 90 plus 90 is 270. Because if you go turn this way, you're going to end up there, or you can turn this way, you still end up there. So the answer is both correctly. Clockwise 90 or counterclockwise 270, both of them correct. Okay?
Remember, when we rotate a figure, the new figure is called the image, and the original figure is called the pre-image.
Rotate the triangle to match the target.
All right. Tell me, the yellow one, we're going to match it with the blue. Oh, okay. You can just log in anytime, okay? Sometimes it happens. Yeah. Okay. Okay. Whenever you give the angle, you also need to tell, like, is it clockwise or counterclockwise? Okay. You need to give the both. Clockwise 90 degrees or counterclockwise 90 degrees or clockwise 270 or counterclockwise 270. That's why you need to give the answer. Not just, yeah, I like that. Allison, see, clockwise 90 degrees. Okay, that's why you need to give the answer whenever you give the answer for this. See, like that. And Alicia, 270 degrees clockwise. That makes sense. And then we can see what else the other way you can do it. Watch this one. If I go clockwise, 90, 180. If I do one more, it's going to be 270.
Nice! You rotated the triangle from its original position to the target. You can rotate the triangle 90 degrees counterclockwise.
Did you hear that? So I may try to rotate this one backwards, which is counterclockwise 90 degrees. So you can say CCW counterclockwise 90 degrees. That is also correct. Or clockwise CW 270 degrees. That is also correct. So when it comes to the rotation, both ways you can do that. Does that make sense? Do you want me to go over, or you guys are good to go? Put them in the chat box. Okay, that's good to go. All right.
Or rotate it 270 degrees clockwise to match the target.
Rotate the trapezoid to match the target.
Now think about it and tell me, is it clockwise, how many degrees, or counterclockwise, how many degrees? Type it in the chat box. Okay. Good, I got a couple of people, yeah. Keep thinking. Don't just follow somebody's answer or anything like that, guys. Here, because I'm not gonna count for the wrong answers, not gonna count for the right answers. I want you to count for the participation. So don't follow somebody who said, okay, I need to follow the same thing. So, because they may be wrong. I like that. So I see a CCW 270 or a CW 270, and I also see a CCW 180. Okay, and CW 180. So we can see that one right now. Let's check it out. So I did a clockwise 90, and I'm gonna do one more clockwise 90.
Affirmative. You rotated the trapezoid from its original position to the target. You can rotate the trapezoid 180 degrees clockwise, or rotate it 180 degrees counterclockwise to match the target.
You see that? 180 degrees clockwise or the 180 degrees counterclockwise, you're going to get the same picture. Does that make sense? Oh, I like that. Unless, yeah. Oh, yeah, that is true. See, that's what we're doing it here. We're learning the stuff. Okay? You may not learn this one before, but now when I'm teaching this one, it makes sense to you guys. It understands better. So that's the reason you need to focus. And also, some people kind of like late to the classroom. I always discourage to come late to the classroom, especially with a math class. You may miss the first few concepts, and the rest of the lesson is not going to make any sense. Okay, so please try to be on time or before time. That helps you to, what is happening in the classroom.
Let's look when you rotate a figure 180 degrees. You don't have to say clockwise or counterclockwise. The result is the same either way.
Okay, so either is the clockwise or the counterclockwise, the results will be the same thing. Okay.
What do you notice about the original trapezoid and its image?
Okay, I want you guys to read 1, 2, 3, 4, or the A, B, C, D, and which one do you guys think it is correctly? It's right thing about the rotations. Read it carefully and answer in the chat box. Okay, alrighty. Let's see. We know rotations, reflections, and translations. They always keep the same size and same shape. Okay. So the first one, sides lengths are same. Yes, that's right. Rotations, angles measure same. Yep. Angles doesn't change any. Parallel lines are parallels. Yes, they are true. So yeah, you guys are right. D is correct. All three statements are correct.
Yep. All three of these are correct.
So, just like translations and reflections, rotations result in congruent figures. Rotations map line segments to line segments that are the same length, and angles to angles that have the same measure. They also map parallel segments to parallel segments. When you rotate a figure, the only thing that changes is its position and its orientation. The longest side is on the bottom of the original trapezoid, but after the rotation, the longest side is on the top of the image.
One thing it's really important in the reflections or the rotations, the orientation will change. In this picture, the trapezoid is the small side is like the smallest or the longest side is on the bottom, but when we rotated it, it becomes on the top. But if you do a translation, which is slide, the orientation will be always same. Okay?
Means the orientation changed. Cool. I think we're getting a good handle on how we're going to get jiggy with it at the dance. But there's a problem. How are we going to get the word out?
Max is right. Flash mobs are spontaneous, and sometimes the people involved don't even get together to practice first. So how can we let the people know what dance moves to do?
A lot of flash mobs are planned through social media. We have to be able to describe to people how to perform the transformations that will make up the flash mob dance.
Ooh, I know! The dance floor has tiles, so we should be able to send messages telling everyone their starting and ending positions. We can even turn on the axes and use coordinates to help. Let's see what happens to the coordinates of points when you rotate a figure. We'll focus on point A. When you rotate the triangle 90 degrees clockwise, the coordinates of the image of A are 3, -2.
Cool. I think we're getting a good handle.
Let's rotate the
Cool.
Let's rotate.
First of all, let's look into the first one. When I rotated the first one, the ABC, 90 degrees, look at that, the order pair A, which is 2 and 3. When we rotate it 90 degrees, it becomes 3, -2. You understand that? So carefully observe it from the A, order pair 2, 3. When we rotate it, it becomes 3, -2. Let me see if I see any pattern in there. What happened? I see the numbers are the same, but only thing the sign is changing. What do you guys think? What do you guys come up with a pattern when it turns 90 degrees? Put them in the chat box. I'm going to give you guys a minute to think. See if you guys find some pattern, just like we did in the translations and reflections. Okay. All right. So when you have a order pair, that's good. Yeah. Thank you. So when you look at this one, definitely I can say A is 2, 3, right? A is 2, 3. But when turned to 90 degrees, this is what I observe. The A x coordinate, which is 2, becomes negative, and then swap the places. That's what I see. See the first 2, 3 is there, the original. That the first x coordinate becomes negative, and then they switch the places. Do you guys agree with me? Put them in the chat box. Okay, let's answer this one, and then I'll answer those questions in easier. Okay, so the first thing is 2, 3. It's first the x coordinate becomes -2 becomes +2, and then it's swapped. So if I follow the same technique, let's see.
The triangle 90 degrees clockwise again. Input the coordinates of the point that corresponds to A after the triangle is rotated another 90 degrees clockwise.
So if I turn it one more 90 degrees, now let's see, let's follow the same logic from 90 to 180. So the x is 3 now. I'm going to switch it to the negative. That's going to be -3, and then I swap them. So -3, and then I'm going to swap them. I'm thinking I'm going to get -2, and the other one is -3. So what I did, I coordinate x, I swapped it to the negative, and then I switch it. Okay, now I'm going to check it whether I did it correctly or not.
Ooh, nice job!
Hold up. I think I see a pattern here. Let's rotate the triangle another 90 degrees clockwise.
So if you turn it one more 90 degrees, I'm going to follow the same technique. So the 180 degrees is x coordinate is -2. I'm going to switch the sign first. So that's going to be +2, and I swap again. That's why I get -3 and 2.
And then all the way back to the original triangle.
So when I swap it to the one more time, the -3 from 270 becomes +3, and then I swap them back. And then when I swap them back, then I get 2 and 3. You see the first as the original, we got again 2 and 3. So when you turn it 360 degrees, you're going to end up at the same place. So just like in triangles, 90, 180, 270, and then 360, then come back to the actual place. So I'm going to give you guys a minute to see, watch carefully, observe that. The logic we talk about right now. See if that makes sense or not. Okay, does it make sense to you guys? Put them in the chat box. If you want me to repeat it, I will definitely want to go back and repeat it, but if you understand, put them in the chat box, please. Okay, that's good. Thank you. All right, that looks make sense. Pretty good. Let's see.